So let's try one example using Hooke's law and attempt to find work done with a spring force. Here we have a horizontal spring with a K value or a spring constant of 80 newtons per meter. It's going to be held fixed at one end and then be allowed to stretch from there. We're looking at stretching the spring from its equilibrium position, which remember equilibrium is at x equals 0, and stretching it out to a 4 centimeter displacement. We want to find the work done by the external force. So maybe this is the person or some object that is pulling on the spring and applying their force here. So remember, when we say that the force applied by the spring is a negative kx, the force applied by the person is now going to be equal and opposite. So the force applied by the person would be like a positive kx. Now in finding the work done by that person, remember, our definition for work is the integral of that force with respect to x. And we are looking from stretching the spring from 0 to 4 centimeters. So we can set up an integral that goes from 0 to 4 of kx dx. When we integrate, we know that again we want to raise the power of the variable by 1, so the x becomes an x squared. We would have now divided by 2, and we are evaluating from 0 to 4. In this case, that was 4 centimeters, so we do want to be careful about that and be sure that as we evaluate, we're really plugging in like a 0.04 as that value to put everything into those SI units of meters. Now when we evaluate this from 0 to 0.04, we can plug that in. So we would take 1/2, K is 80. We'll plug in the x of 0.04 and square it, and subtract what we would get when we plug in the 0 value, which would just be a 0. If you'd like to take a second and pause the video to plug this into your calculators, you'd find that this amount of work would be 0.064 joules of work. The second question asks what the additional amount of work would be to stretch the spring from the 4 centimeter mark to the 7 centimeter mark. In this case, we still want to look at work as the integral of the force. Again, the force that we're looking at is the positive K, which is 80, x dx. This time we're going from 4 centimeters to 7 centimeters. So we would integrate from 0.04 to 0.07. In doing this, again, we want to raise the power of the x by 1, so it's going to be squared, divide by a 2, and then evaluate from 0.04 to 0.07. Again, you may want to plug in these values on your own, but basically what we have here is the 40 outside, and then inside we have the 0.07 being squared minus the 0.04 being squared. So just another way that we could write out that work that we were doing. Ultimately, when we solve for W and the amount of work done to go from 4 to 7 centimeters, we'd find that we would need an additional 0.13 joules of work. So here's one example of, again, utilizing both Hooke's law for the general equation of the force applied by a spring, and also utilizing our better definition of work as being the integral of that force with respect to position.